Hey students, today from this video we are going to start learning equilibrium of co-planar system of forces. Basically in this video I am going to introduce you to supports and support reactions. Also I am going to introduce a very important concept, two force member. But before we begin, those students who are new to my channel, this channel is basically for you to make your concepts clear, to make you fluent and confident in solving problems on engineering mechanics, strengths of materials and engineering graphics. If you will find this video valuable to you, consider subscribing my channel, press the bell icon so that you will not miss on important videos I am going to publish. So let's begin. Equilibrium of coplanar system of forces, supports and corresponding reactions. So first type of support, it is smooth surface or smooth contact. For example, here is a smooth surface. It is permanently stationary surface or fixed surface. So this is the notation used for a permanently stationary surface or the surface which is part of ground. This surface is supporting a box. So imagine a box is supported by a floor. Neglecting friction here, we can say that it is a smooth contact. When two bodies are in contact, then they exert force on each other. So here the box is exerting force on the floor is exerting force on the box. When you talk about support reaction, it is a force exerted by the support on the supported body. So force exerted by the floor on the box, that is support reaction here. One more example of this type of support, smooth surface or smooth contact. Here there are two inclined surfaces. The surface on the left side makes angle 45 degrees with the horizontal and surface on the right side say makes 20 degrees with the horizontal. These two surfaces are permanently stationary surfaces and these two surfaces are supporting a roller. Now this roller again experiencing reaction. Where the roller is experiencing reaction, this roller is experiencing force at this contact, that is reaction by this inclined surface, and this roller is experiencing force at this contact, nothing but the reaction or force by this inclined surface. When you want to show reaction by a support on supported body, then there is nothing to think here. Support reactions is a very standard set of forces and it depends on the type of support. So you will have to just remember support and corresponding reaction combination. So reaction at smooth contact is normal to the surfaces in contact and towards the body under consideration. It is always a push type of force. If you try to move box leftward, rightwards, it will move leftward, rightward because there is no constraint on the left side or right side. If you try to lift the box, then if enough force is applied on the box may get lifted. But if you try to push the box downwards, then the surface will not allow it. That means this surface will create upward force. If box tries to move downwards, if you try to push box downwards, there will be upward force. So we say that here reaction means the force exerted by this horizontal surface is push type of force. Remember in short in this manner, normal push. Now very important thing, force is associated with three parameters: magnitude, direction and point of application. So with a force, three parameters are involved. Sometimes all these three parameters are unknown, magnitude unknown, direction unknown, point of application unknown. But sometimes only two of them are unknown, or sometimes only one of them unknown. So accordingly, a reaction is associated with number of unknowns. And remember, number of unknowns associated with the particular reaction. For example, here number of unknown is 1. How come? I am going to explain you. Now, how to show this reaction? If you want to show reaction at this contact, in the sense force exerted by the support means this horizontal surface on the box, then remove the support, that is remove the surface and replace it by force. So this is how I have shown the force by the surface. It is normal to the surfaces in contact. So surfaces in contact are horizontal, so reaction is vertical. But not only that, it is towards the body under consideration. So the support is below the box. So from below, it is push type of force, that is towards the box. And this is very important to understand. When in a diagram, in space diagram or in free body diagram, you want to show force by a body, you should remove the body and show its force. Remove the surface and show its force. So this is how we show reaction after removing the surface. Okay, this is normal push. Normal to the surfaces in contact. So here I am going to show reaction. So nothing to think here. It is force exerted by the support, means by inclined surface. So we'll have to remove the inclined surface. And we'll have to show push type of force. But most important thing is, it is normal to both the surfaces in contact. At the point of contact, normal is nothing but the radius, and radius always pass through the center. So first establish the center of the roller. So here I have established the center by drawing a line horizontal and a line vertical. And at the point of contact, we are going to show reaction here. This is that line. At the point of contact, it is radius of the roller which is extended. So this line is along the radius, means a normal to the circle at the point of contact. But not only that, this line is normal to the inclined surface also. And therefore, if inclined surface makes 45 degrees with horizontal, normal makes 45 degrees with vertical. So this is very important. If inclined surface makes 45 with horizontal, then its normal makes 45 degrees with vertical. So along the normal, we should show reaction. So this is the normal reaction at this contact. Same way here, surface makes 20 degrees with horizontal, normal makes 20 degrees with vertical. And not only that, since that normal is normal to the circle, it should pass through the center. Correct? So here, it is normal. It is normal to the surface, and that is why it is at an angle 20 degrees with vertical. And not only that, it is normal to the circle, so it should pass through the center, and this is how remove the surface and show the reaction. And it is push type of reaction. So simple, at smooth contact, this is how we show normal reaction. Second type of support, it is roller support. Now for example here, rollers themselves cannot support a body. So first of all, rollers are to be supported on a surface. This is the stationary surface on which rollers are resting. And these rollers are in turn supporting a box now. So here, this entire assembly of these rollers and the surface form a type of support, we say roller support. And the supported body is the box. So how to show reaction by roller support? It is normal to the surfaces on which the rollers are resting. Rollers are resting on horizontal surface, so it is vertical reaction. Not only that, it is towards the body under consideration. So from this surface side, it is push type of force. Towards the box means push type of force. So here also, like smooth surface contact, here you remember roller support reaction as normal push, simple. But what about number of unknowns? So here also there is only one unknown involved. And what is that unknown? Magnitude of the reaction, because you will be knowing the point of application of the reaction. It is where the support is, the reaction is. So point of application of the reaction will be known to you always. Then what about direction? It is always perpendicular to the surface on which rollers are resting. So if you know that rollers are resting on horizontal surface, then it is vertical surface. If rollers are resting on a surface that makes 30 degrees with horizontal, then reaction makes 30 degrees with vertical. So point of application, angle of the reaction theta will be known to you always. The unknown will be magnitude. So roller support reaction, only one unknown involved. So remember, it is support to be removed and reaction to be shown, and it is a push type of reaction, that is towards the body under consideration. So check on which side the support is, and from that side it is push type of reaction. Okay, now there are different ways to show a roller support. So here rod is supported at its left end by a roller support. So this is how it is shown. Right now don't worry about how it is supported at the right end. Just focus on the support on the left side. So this is how a roller support is shown in the diagram. So this entire assembly, that is this U-shaped portion, this dark point, that is pin involved here, and these are rollers and this surface, this entire assembly is a support and known as roller support. Here the rod can roll at its left end, rod can roll on this surface because there are rollers involved. This is one more way to show a roller support. Now you cannot see any roller here, but this is one of the standard way to show a roller support. Can you see here the gap? In this gap we should imagine rollers. And one more method to show a roller support. Roller support may be shown in this manner. In all the three cases, because it's roller support, you should show reaction normal push, normal to the surface on which rollers are resting. This is the body supported horizontal rod. On which side of that rod the surface is, from that side normal push, and normal push. This is how we show reaction. Number of unknowns 1. Next type of support, that is wire support. Now here rod AB, don't worry about how it is supported at its end A, just focus on the support at end B. It is a wire support. Rod AB is supported by a wire at its end B. Here rod AB is supported by a wire at a point on the rod, at point C. Okay, how to show reaction here? Nothing to think here. Wires always pull. Wires always pull the bodies they are supporting. So pull type of force along the wire. This is how we show reaction, always. So wires always pull the bodies they are supporting. Remember this. And number of unknowns involved? Only 1 again. The reason is, force by wire is always along the wire. So reaction, that is force by wire, its angle is known. That is nothing but the angle of the wire. Point of application, of course, B. So only unknown is magnitude of the reaction. That is why we say number of unknowns 1. So how to show reaction? Remove that wire support and show the reaction in this way. It's pull type of force. Pull along the wire. Similarly here, at point C, just remove the wire and replace the wire by the pull type of force. So this is how we show reaction by wire support. Now it's very important to remember these points. A straight portion of a support wire is a two-force member in tension. Two-force member in tension. Now what do you mean by a two-force member? Watch here this wire. Bodies experience force where they are in contact with the other bodies. Now here wire BC, imagine no other force on this wire. So wire BC is in contact with the stationary surface at point C, and here the wire is in contact with rod AB at point B. So this wire is experiencing force at B and also a force at C. So this wire is experiencing two forces, one at end B and the other one at end C, and therefore we say that wire BC is a two-force member. Similarly, this wire CD is experiencing force at C and force at D, and therefore we say that the wire is a two-force member, a member acted upon by only two forces, that is two-force member. So remember, force by wire is a pull type of force. Force by wire is a pull type of force. And wire is always a two-force member in tension. Since the wire experiences pull type of force at its ends. Therefore, we say that wire is a two-force member in tension. So check here, this wire is pulling rod AB, this wire is pulling rod AB. Remember, when you want to show force by a wire support, show pull type of force. Fourth type of support, it is rigid two-force member. Listen, earlier we talked about wire. Wire is a flexible thing. And I told you that wire is always a two-force member in tension. I explained you what is a two-force member. Simple, a member acted upon by only two forces. Why rod BC is a two-force member? Listen to me very carefully. Why rod BC is a two-force member? Because rod BC is experiencing a force at B and force at C. And therefore we say B and C are the 2 points of application of forces for this rod, for this two-force member. And reaction by rod BC on rod AB, force by rod BC on rod AB. In other words, force by this two-force member on rod AB is either pull or push along the line joining the 2 points of application of forces, means along line joining BC. So remember, force by rod BC, a two-force member, is along line joining its two ends. Now it is either pull or push, that depends on the forces acting on the supported body. So rod AB, imagine many forces acting on rod AB. So it can be pull, it can be push. But before analysis, you will not be knowing whether it is pull or push. And therefore, in space diagram or in free body diagram, always assume pull. Always assume pull type of force. So number of unknowns involved here is again 1, because line of action, that is angle theta, will be BC, point of application will be B. When it is force on rod AB, it will be at point B. So point of application, angle theta will be known, so only unknown will be the magnitude of the reaction. And how to show the reaction? Remember this, it is pull along the line joining the 2 points of application. So force by this support, this entire assembly is to be considered as a rigid two-force member support. And how to show reaction? Watch here. Along BC, pull. Along the line joining the 2 points of application of forces. So along BC, pull. This is how we show reaction. Along line BC, pull. Just replace that two-force member and show pull type of force. This is how we show reaction by a rigid two-force member. But what's very important is, the member is a two-force member, you must be able to identify that as a two-force member. Rod AB, as I told you, imagine many forces acting on rod AB which are not shown in the diagram, but let's assume that there are so many forces acting, there is gravitational force acting on rod AB. So since there are many forces acting on rod AB cannot be a two-force member, but this rod is weightless rod, as I told you, connected at its ends only. No force acting in between ends. No couple is acting on rod BC. So rod BC is a two-force member. No other force or couple acting, only forces at these two ends. That is a two-force member. And how to show force by a two-force member? Pull type of force. It is to be assumed, means you may get negative answer depending on the forces in the system. Okay. So it's not necessary that a two-force member is a straight rod. It can be a bent rod. For example, here. So rod AB, this horizontal rod, is supported by, you are familiar with this type of support. It is roller support. It's supported by a roller at its end A, and it is supported by a bent rod at point C. Now, right now we are talking about a rigid two-force member. So, how to show reaction by this member? So, simple. As I told you, religiously follow this statement. Assume pull. It can be pull, it can be push. Assume pull, but along the line joining the 2 points of application of the forces. So, rod CD, this two-force member Why it is a two force member? It is connected at ends only. No force in between ends. No couple is acting on it. So it is a two force member. Bent rod is experiencing force at C and force at D. So along line CD, you are going to show that reaction. Angle of this line is known to you. What is that? Tan inverse 5 by 4. Focus on this right angled triangle. Focus on this right angled triangle. So opposite side by adjacent side, this angle you will get. And the same angle appears here. So that we can write here 51.34 degrees. It is tan inverse 5 by 4. So along this line, the reaction is. Remember, when we solve problems, you may get negative answer for force by a two force member. What does that mean? Since we have assumed pull, assumption was wrong and the correct direction is push towards the body. Angle remains the same. So this you should not forget, it is assumed direction. It's always better to assume pull type of force by a two force member. Now, a rigid two force member either pulls or pushes along the line joining the 2 points of forces. Remember. Now watch here. You are familiar with this type of support. If you want to show reaction at this roller support, how will you show it? In the same video, we have studied earlier how to show reaction by a roller support. Normal to the surface on which rollers are resting. So surface makes 30 with horizontal, so reaction makes 30 degrees with vertical. And it is push type of force. So showing reaction is not a problem. It only depends whether you remember or not. Now, next type of support. It is hinge support. So here rod AB is supported by a hinge support. This is how a hinge support is shown in the diagram. This U-shaped portion is rigidly connected to the wall. That is, it is integrated part of this wall or the stationary surface. And it is pinned here. What we say, the horizontal rod is pinned to the wall. So this is pin support or hinge support about which body can rotate. So it is a force. Reaction at pin support is a force. But what about its magnitude and direction? Depends on the other forces acting on rod AB. So reaction at hinge support is a force. Magnitude and direction depends on the other forces on the body. So there are two unknowns involved with reaction at A, magnitude and direction. Point of application, its reaction at A means point of application is nothing but point A. So three parameters associated with reaction at A. Point of application is already known as point A. So magnitude and direction, these are the two unknowns. Now in free body diagram or in space diagram, we show reaction by hinge support using components. And we assume these components rightward and upward. It's always better to assume positive components, rightward and upward. And number of unknowns involved here is 2. Do you remember earlier 4 types of supports? In each of that support, number of unknowns was 1. But in the case of hinge support, number of unknowns are 2. Now how to show reaction? Watch here. You want to show reaction by this hinge support or this pin support. So remove the pin support first. And then nothing to think here. When it is a pin support, it is to be replaced by reaction in this manner, rightwards and upwards. Rightwards and upwards. These are assumed direction, so you may get negative answer. Now one very important thing here, watch here. This is a hinge support. And we say that rod AB is hinged to an inclined surface. But how to show reaction at hinge support? Read it. Rightward, upwards. Simple. So that means this angle 30 degrees has no significance at all. This angle 30 degrees has no significance. So show hinge reaction rightward, upward. So what you should understand here, hinge reaction to be shown rightwards, upward. And nothing to do with the inclination of the surface to which the body is hinged. So if here surface is at an angle 60 degrees or 30 degrees or vertical or horizontal, In all these cases, you are going to show reaction rightward upward. So when it is a hinge support, reaction to be assumed rightward upward. Remember. Now next type of support, that is fixed support. Fixed, rod AB is fixed. You will be having that information that rod AB is fixed at its end A. And when you have that information that rod AB is fixed at its end A, now you know that all possible motion, that means translation is prevented, rotation is prevented. And therefore we say reaction at hinge support is a force and a couple. And what is magnitude and direction of the force? Depends on the forces acting on the supported body. So we show actually three components. The force in its two components, rightward upwards, and the couple is the third component. It's always assumed, it's assumed direction for all these three components. Horizontal force we assume rightward, vertical force we assume upwards, and reactive moment we assume anti-clockwise. So how to show reaction at fixed support? Remember in this manner, rightward, upward, anti-clockwise. Rightward, upward, anti-clockwise. So two force components and a couple. Number of unknowns involved here are 3. Now listen, to remember number of unknowns involved in these different types of supports, that's not a problem at all. There is only one support where we count 2 unknowns. That is hinge support. And there is only one support where we count 3 unknowns, and that is fixed support. So how to show reaction here? Remove the support, rightward, upward, and anti-clockwise. Now, these are the 3 unknowns involved in a fixed support. So support reactions is standard set of forces according to the type of support. So while solving problem, showing support reactions is not a problem at all. You will just have to remember these types of supports and corresponding reaction. Let's revise it. Smooth contact reaction, it is normal push. Roller support reaction, it is normal push. Wire support reaction, it is pull along the wire. A rigid 2 force member, assume pull along line joining ends of the 2 force member. Hinge support reaction, assume rightward, upward. Fixed support reactions, assume rightwards, upwards, anti-clockwise. And there is one more type of support. It is 7th type of support, rod collar or slider slot support. In this case, I have shown slider slot support. That is, this rectangular block is slider and it can slide inside this slot. Rod collar is similar type of support where collar is a box like this slider. Here collar is a slider which slides on a rod. Like curtain rings can slide on the rod, here collar slides on the rod. So functionally both these types of supports are similar. Okay, how to show reaction? Now watch here. Here rod AB. Whether there are other supports or not, don't worry about that. But this is how slider slot support is shown in the diagram. There is a slot involved and inside the slot there is a box sliding and there is a pin here. The supported body means the supported body is pinned to the box. Okay, so because it is a pin joined with the box, this rod can rotate about point A. So rod AB is free to rotate about point A. Rod AB can move rightwards, leftwards because rod AB is connected to a slider which can slide rightwards, leftwards. But rod AB cannot move upwards or downwards because this rod is connected to a slider which cannot move upwards, downwards. So this entire assembly, the slider, the slot and the pin, this entire assembly is slider slot support. How to show reaction? Simple. A force, reaction is a force normal to the path of the slider. So path of the slider is horizontal line. This slider can slide horizontally. Inside the slot it moves. So its path is horizontal. So in this case reaction is vertical. So reaction by a slider slot support is a normal force normal to the path of the slider and in assumed direction. So direction to be assumed. So watch here, the path of the slider I have shown here. So this is the path of the slider and perpendicular to path of the slider, normal to the path of the slider, I have shown the reaction. Now the problem is, why upwards? Why not downwards? So it's assumed direction. So direction to be assumed in FBD, free body diagram or space diagram. Direction to be assumed. About free body diagram we'll talk later. In FBD or space diagram, FBD is very much similar to the space diagram, and I'll make a separate video on FBD since it is very important concept. In FBD, assume the direction of the force along its line. So in a diagram, when you show force by slider slot support, it is to be shown perpendicular to the path of the slider and in assumed direction. So it can be shown downwards also, no problem at all. But when you assume direction, it's better to assume positive direction. Okay. So negative answer is possible. And number of unknowns involved. Now watch here. Since you will be always knowing path of the slider or path of the collar, you will be always knowing angle made by the reaction with a reference line. Point of application, of course, the point where the support is. So only unknown is magnitude of the reaction, and that is why we say there is only one unknown involved. So you must be able to count a number of unknowns at each support. But is it difficult? Of course not. Of course not. Because there is only one type of support where we count two unknowns, that is hinge support, and there is only one type of support where we count three unknowns, that is fixed support. And in all other types of supports, you are going to count only one unknown. That's it. Thank you so much for being here. I am truly honored and grateful to serve you. And remember, subscribe my channel, share this video with your friends. Don't forget to like the video. Don't hesitate to comment on the video. So I'll meet you in my next video. Have a beautiful day.